Okay, today we're going to be going over curvature along with velocity and acceleration. So the first thing that we're going to go over is what a position vector is. So a position vector is just our normal vectors that we're used to working with, where our curve is on a graph, which is x of t, y of t, and z of t. And then just a reminder that our velocity vector is just going to be the derivative of our position vector, so this is just going to be x prime of t, y prime of t, and z prime of t. And if we had a curve here, what our velocity vector would be our tangent. So this is our v of t. And this point here is going to be our position vector. And this curve here is going to be our position vector, which also means that our velocity vector is equal to the derivative plus the derivative of y with respect to t plus the derivative of z with respect to t. So next up we have the unit tangent vector at t, which is going to be a capital T of t, which is equal to the velocity vector divided by the magnitude of the velocity vector. And then finally we have to find the acceleration. So our acceleration is just going to be our a of t, which is the derivative of a velocity vector, or the double derivative of our position vector. And then finally we have our normal vector is equal to the derivative of t divided by the magnitude of t. So the first thing we're going to do is the curvature of a circle, with the formula of a circle being x squared plus y squared is equal to a squared. So the first thing we're going to do here is make our x equal to a cos of t and make our y equal to a sine of t, which makes our position vector equaling to a cosine of t and a sine of t. And then to find our velocity vector, we just take the derivative of our position vector, which gives us negative a sine of t and a cos of t. So now, if you remember, to find the curvature, we need to find the tangent vector, take the derivative of it and find the magnitude, and then divide it by the magnitude of the velocity vector, which is our v of t. So what we could do here is we could find the magnitude of our velocity. So our magnitude of velocity is going to be equal to the square root of negative a sine of t all squared plus a cos of t all squared, which is going to be equal to, we can make these a squared, and then it'll be sine squared of t plus cos squared of t. So this will just become 1, and then a squared multiplied by 1 is just a squared, giving us just a from the square root. And since we have to find our tangent vector, which is going to be equal to our velocity vector divided by the magnitude of the velocity, this is going to be equal to negative a sine of t and a cos of t divided by our magnitude, which is just a. So we can cancel all the a's, so this will be equal to negative sine of t cosine of t. And now we need to find the derivative of the tangent to get one step closer to finding our curvature. So now this is just going to be equal to the derivative, which is going to be negative cosine of t and negative sine of t. So now our last step is going to be finding the magnitude of our tangent, and then we can plug our numbers into the formula. So it's going to be the square root of negative cosine of t all squared plus negative sine of t all squared. And since this is just going to be cosine squared t plus sine squared t, this is just going to be equal to 1, which gives us our final answer of 1 divided by a. And what this means is, in a circle, the curvature of a circle is always going to be 1 divided by the radius, or in this case is going to be 1 over a. So now we're going to find the curvature of a helix. So we're going to start off with finding our position vector, which is just going to be equal to a cosine omega t, a sine omega t, and rho t. And now we'll find our velocity vector. Negative a omega sine omega t, a omega cosine omega t, and then just rho. So now our next step will be is just finding the magnitude of our velocity, which is going to be equal to the square root of negative a omega sine omega t all squared plus a omega cos omega t all squared plus rho squared, which will give you the square root of a squared omega squared plus rho squared. Because when we get our sine omega t squared plus cos omega t squared, we can just take those and make them equal to 1, and then factor out our a squared omega squared from both of them. And now we have to find the tangent, which is going to be equal to our velocity divided by our magnitude of our velocity, which is going to be equal to negative a omega sine omega t, a omega cos omega t, and rho divided by the square root of a squared omega squared plus rho squared. So now to find our curvature, we're not going to be working in the regular tangent. We need to be working in the derivative of the tangent. So we need to find t prime of t, and since we're finding it with respect to t, we can just take out the denominator since nothing there is with respect to t, and then only focus on the numerator. So this will become negative a omega squared cosine omega t, negative a omega squared sine omega t, and 0, divided by the square root of a squared omega squared plus rho squared. And now our final step is going to be taking the magnitude of this. So our magnitude of t prime of t is going to be equal to the square root of a squared omega to the 4 cosine squared omega t plus a squared omega to the 4 sine squared omega t divided by our a squared omega squared plus rho squared. And then finally, to find our curvature, we need to take our tangent and divide it by the velocity, the magnitude of the velocity, which is going to get us 1 over v multiplied by the derivative of the magnitude of the derivative of the tangent, which is going to be equal to the square root of a squared omega to the 4 cosine squared omega t plus a squared omega 4 sine squared omega t, all divided by the square root of a squared omega squared plus rho from here, and then we have to multiply it by the magnitude of our velocity, which is the same thing as a squared omega squared plus rho squared, which, if simplified, will give us our final curvature as equal to a omega squared divided by a squared omega squared plus rho squared. And then something to note for a helix, since it looks like this in 3D, it is wrapping around. Our rho is what's causing our height. So if our rho is equal to 0, the helix just becomes a circle.